Now my screen is visible, isn't it?
Yes, ma'am. Visible, ma'am.
Okay, okay, okay. Okay, okay, Amma, I will start with closed loop control system. Yesterday we have seen open loop control system. Okay, so in the case of open loop control system, for the given input to the system, the output may not be controlled. Means whatever input that I give, okay, the input has to do nothing with the output. Even if the output is not corresponding to the input that is given, input cannot do anything for that. Okay, so the output cannot be controlled by the system. Okay, so output cannot be controlled by the system in the case of open loop system, whereas in the case of closed loop control system, the output can be controlled. Okay, so here if you see here, control system in which the output has an effect on the input quantity in such a manner that input quantity will adjust itself based on the output generated. Okay, so input will adjust itself in order to vary the output. In the case of open loop, input cannot be varied. Once it is given to the system, even if any sort of disturbances occur in the system, it has to do nothing with the input. Whatever output is generated, that's it, that's all. Okay, whereas in the case of closed loop control system, the input value can be varied to get the desired output. Okay, in order to get a controlled output, we should always use, or in order to get a desired output, we should always use a closed loop control system. Okay, so simply if you have an open loop control system, if I am able to give a feedback to the open loop control system, means feedback means a connection from the output terminal towards the input terminal. Okay, so if I am able to give the feedback from the output terminal towards the input terminal, then open loop can be converted into a closed loop control system. Okay, so the feedback automatically makes the suitable changes in the output due to external disturbance. Okay, so in this way, closed loop control system, you can even call it as automatic control system. Closed loop control system, you can call it as automatic control system, Mama. So yesterday I was discussing about this actually. Okay, so this is the block diagram representation of a closed loop control system. So whatever input that you want to give to the process or the plant, okay, that input is actual input is known as command input. Okay, so the command input may not be in the same nature of your process as well as your controller also. Controller is nothing but a computer or a microprocessor. Okay, the controller is, it can be a computer or a microprocessor or any digital circuit. Okay, so the nature of the controller and process will be almost same. Okay, so the nature of the command input should be of same nature as that of your processor, process or plant and controller. Okay, so the nature should be same. Okay, or sometimes whatever input that I am giving, command input that I am giving to this, okay, that command input may be too large to accept by this plant or the process. So it has to be reduced. Okay, sometimes the command input has to be amplified. You know what is meant by amplification because you are electronic student. You might be already known. Okay, so sometimes input has to be reduced. Sometimes input has to be amplified, or sometimes the nature of the input is to be changed. Yesterday I have already explained you how from what nature to what nature the input is to be changed. Okay, so in order to reduce the input if required, in order to change the nature of the input if required, in order to amplify the input if required, we need a reference transducer. Okay, so whenever I am unable to connect a direct input to the controller or the plant, okay, so I will use a reference transducer which will, what it will do, it will convert the input in the nature of this controller and plant. Reference transducer converts the input into the nature of the plant. Okay, so whatever input is given to the reference transducer, it will generate, and the output of the reference transducer is the reference input. Okay, the transducer output is the reference input R of T. Okay, it is R of T. Okay, so R of t is given as input to the controller. Forget about this error and error detector. I will explain it to you later on. Okay, R of t is given as input to the controller. It can be a computer, it can be a digital circuit, or it can be a microprocessor. It will manipulate the variables. Okay, so it will manipulate whatever means it will convert that reference input that is given to the controller into the nature of the plan, and it will generate an output which will be accepted as input to the processor. Okay, so controller, all the commands will be fed in the controller. Okay, so whatever commands are fed in the controller, based on those commands, it will generate an input, an output M of t. Okay, it will generate an output M of t. Okay, wait, where is my screen? It will generate an output M of t. I wanted a pointer. Wait, this is my pointer. Okay, it will generate M of t. Not that right. Ballpoint. It will generate an M of t. Okay, the output of the controller is M of t, which will be in the nature of the processor, which will be easily accepted by the processor. So processor will, there is an option. Okay, processor will generate an required output C of t. Okay, so for the given input, some C of t output is produced. This output is again fed back to the error detector. Okay, by a feedback element. Okay, by a feedback element, this output is fed back. Okay, so C of t is given to a feedback element. Okay, so the feedback element will generate an output. Okay, whose nature will be similar to the input of your controller. Okay, so B of t is fed back. Okay, and this error detector, what it will do is, it will see whether R of t is same as B of t or not. Okay, R of t and B of t should be same. R of t and B of t should be same. If they are not equal, okay, if they are not equal, an error signal is generated which is known as P of t. Okay, so the difference between R of t and B of t should be 0 always. Okay, so whatever input that I give, okay, the corresponding output I should get. Okay, 1 minute. Okay, so whatever input that I give, corresponding output I should get. If I am not getting the corresponding output, means if due to some disturbance in the plant, the C of t may vary. It is not the desired one. So if the C of t is not the desired one, if the output of the process or the plant is not the desired one, then there will be a difference between R of t and B of t. So the error detector will calculate the difference between these two. Okay, if the difference is 0, the error is 0. Okay, the difference is 0, the error is 0, and there is no role of the controller here, because no error, then controller will not do anything further. Okay, if there is some difference between R of t and B of t, then an error signal E of t is generated, which is given to the controller. The controller will manipulate it and convert it into the desired form, and it will generate an M of t. Okay, it will generate an M of t. Right. Okay, that's right. Okay, so it will generate an M of t. Okay, so this M of t is given as input to the processor, and you will get a controlled output. Okay, that's all. So here you see here, this is a feedback element. Okay, directly I cannot connect. Okay, I cannot connect C of t to this error detector. Why? Because you are changing the nature of the, okay, as from one element to another, the nature of the signal is changed. Okay, so the nature of the signal here, output of the feedback should be, the nature of this output of the feedback should be similar to the nature of the reference input. Okay, if the nature is same, then only I can subtract. Suppose if I take a binary number, I cannot subtract binary number with a decimal number. Okay. If I want to subtract binary number with any other number, that number should also be binary. Okay. So only binary number can be subtracted from a binary number. Okay. It cannot be subtracted with any other number system. Okay. So that is the same nature. Okay. Then in order to, okay, that's why we need a feedback element which converts the output nature into the nature of the input. Okay. So in this way, if there is any change in the output because of some disturbance I have shown here as external disturbance, it can be within the system, some disturbance may occur, in the controller itself disturbance may occur, in the plant itself disturbance may occur, and output may not be the desired output. Okay, we'll see some examples of controlled closed loop system. Okay, automatic control system. Sorry, not controlled, automatic control system or closed loop control. Okay, we'll see the example. Okay, so you can see here. R of t is the reference, E of t is the output, desired output, B of t is the feedback signal, error signal, E of t is the error signal, M of t is the manipulated signal. Okay, so whatever I have told you, that's what is there. Theoretically, the whole data I'm writing in theory. Okay, so no need to worry. Okay, whatever explanation till now I gave, it is in these two slides. Explanation is in these two slides. Same whatever I have told you is there. Okay, so if you want, you can read here controller modifier the error signal to produce the better control action. Modify error signal back to the plant to correct its output. Okay, now let us see some examples. Okay, so we know in our houses, usually the windows are for the windows we use glass material. Okay, so we use glass material. The reason for using an opaque glass, especially we use opaque glass because opaque glass means we can't see through those glasses. Okay, but sunlight can enter into the house through those opaque glasses. Okay, so 1 minute. I'm taking a screenshot. Okay. So to an opaque glass we can't see through, but sun rays can enter into the house. Okay. Sometimes what happens is if it is very cloudy outside. Okay. So much sun rays cannot enter into the house through the windows. Okay. During that time manually we will turn on the lights if it is darker, even during the daytime if it is darker inside the house. Okay. That's what we will do. Usually that's what we will do. But nowadays automatically switching, turning on and turning off lights have been introduced. Okay, they are there. Most of the people are using. Okay, so in order to turn on the light automatically, in order to turn off the light automatically, then we need a sensor which will sense the daylight inside the room. Okay, so that there will be. If you can see here, I have mentioned these are the windows. This is a daylight sensing sensor which is fixed in the ceiling. Okay, so if the sensor sensors there is less number of light rays are coming in through the window into a room, then the sensor will give signal to the bulb or the tube light or any lamp that is in your house, and that lamp will glow depending on the lighting that is available. Okay, so it is an automatically controlled closed loop system. Okay, I'm sorry. I didn't edit. I didn't edit here. It's not closed loop. I'm sorry. It's not open loop. It is closed loop. Why to rewrite? I I thought why to rewrite again and again, and already simply if I replace open with closed loop, it will become closed loop system. That's what I thought, but it seems I forgot to edit this. Okay, it's an example of closed loop system we are discussing, not open loop system, Amma. Okay, so if we see here, okay, this is one of the example of a closed loop system, Amma. Here, based on the daylight that is available inside a room, okay, a sensor will sense the daylight, and if required, it will turn on, or if required, if sufficient daylight is there, it will automatically sense the sufficient daylight, it will turn on. Okay, one more example, Amma, temperature control. Okay, so there is a water heater is there. Okay, it is in this water is to be heated to required temperature. Okay, so there will be a temperature sensing sensor. Okay, okay. So this temperature sensing sensor will measure the temperature of water when the water is heating, and it will check whether the temperature of the water has reached to so and so degrees Celsius or not. Here there is a temperature is set 140 degrees Celsius. Temperature is set. Okay, so based on the setting, the water should heat up to 140 degrees Celsius. Okay, if any fault occurs, if any disturbance occurs, the water may not heat up to 140 degrees Celsius. Means the temperature of the water will not raise to 140 degrees Celsius. Okay, so if there is no control provided, then we may not be knowing whether the temperature is 140 degrees Celsius or not. That's why if there is a sensor, it will be continuously monitoring the temperature of the water so that the required temperature is maintained. This is one of the example of a closed loop system. Next, Amma, bread toaster we have already discussed in the open loop control system, Amma. The bread toaster is a machine which is run after adjusted time along with light, medium, and dark setting. Means so some people like more crispier toast. Okay, some like a mediumly baked toasted bread. Okay, some people like very lightly toasted bread. Okay, so depending on the requirement of the people, okay, so there are some settings provided in the bread toaster. Okay, that is light setting, medium setting, and dark setting. Depending on that, okay, whatever setting that you want, if you set that, automatically the bread will be toasted and it is popped out. Okay, are you online? Huh?
Yes, sir.
Are you able to hear me? Yes?
Yeah, ma'am.
Yes, somebody, one person, if you speak, it is more than enough.
Yeah, ma'am, it's clear, ma'am.
Clear, ma'am.
Oh, okay, very good. Okay, then advantages of closed loop control system, Amma. Definitely based on whatever discussion I have made for open loop and closed loop system, you might be already knowing that closed loop control system has more advantages when compared to open loop control system. Okay, so closed loop control systems are more accurate even in the presence of non-linearity. Okay, even if the system is non-linear, you know what is meant by linear and non-linear system. Even if a system is a non-linear system, closed loop control system is more accurate. Okay, it is highly accurate as any error arising is corrected due to the presence of feedback signal. Okay, so since we are using a feedback signal here, okay, it is highly accurate. Okay, because of the feedback signal. So bandwidth range is also large in this case of closed loop control system. Okay, facilities are it facilitates automation, means automatically it does all the work. Okay, no need to manually sit and wait and check again and again. Okay, so manual work is reduced. Okay, so manually human involvement is reduced. Automatically it does all the work. So it facilitates automation. Okay, the sensitivity of the system may be made small to make system more stable. Okay, so since it is a closed loop system, it is less sensitive. Okay, so since it is less sensitive, it is more stable. Sensitive means even for small disturbances, if there is large variation in the output of a given system, that means it is a sensitive system. Okay, even for small disturbance, the variation in the output is very small. Okay, then it is a less sensitive system. Closed loop control system makes all the systems less sensitive to this disturbance. So we can call the system as more stable system. Okay. So this system is less affected by the noise. So let us see the disadvantages of closed loop systems. They are costlier because more number of elements are required in the case of closed loop system. Whereas if you might have observed the block diagram representation of the open loop system and the closed loop system, if you compare, in the closed loop system more elements are there. That's why it is more costly. It is complicated to design because more elements are there. Okay, so it requires, since it has more number of elements, it requires more maintenance. Okay, so it has been observed that feedback leads to oscillatory response. Okay, it has been observed that feedback leads to oscillatory response. Overall gain is reduced due to the presence of feedback. Okay, stability is the major problem and more care is needed to design a stably closed loop system. Okay, so just now you may think that in the advantage I have told you that it is more stable. Of course, it is more stable since more number of elements are there. Okay, their operation should be accurate. Okay, more number of elements means chances of more disturbances. Okay, even if one element is unable to operate properly, the output of that element will definitely affect the performance of all the elements. So that's why stability is the major problem in this case of closed loop system. Because while designing itself, everything is perfectly designed, each and every element is perfectly designed, then no issue. Okay. Okay, let us see some examples of control system. Okay, let us start with temperature control system. Then we will discuss same example for open loop and the closed loop. Okay, I am going to discuss only few examples. If you want, you can go to the textbook, different textbooks, you will get more examples. Okay, so in the class itself, we can discuss more and more. Of course, if you want, we can discuss one topic throughout the month. Okay, it depends. Okay, but according to our time limit, so we will discuss. So if you have more interest, you can go to the textbook for more examples. Okay, for the same example, I will discuss open loop system and the closed loop system. Okay, let us see temperature control system. So let us start. Let us see for the open loop system. Okay, so my aim is to get the desired temperature for a system or for certain device. Okay, so I am taking an electric furnace here. In this electric furnace, I want to heat that furnace. Okay, I want to heat this furnace to some desired temperature. Okay, I want to heat this furnace, that's all. Okay, in order to heat the furnace, I need an heating element. Okay, I need an heating element to heat the furnace. Okay, so this heating element is connected to the supply with the help of a relay control circuit. Okay, so relay, actually in electrical engineering, relay is the one which senses the fault and sends signal towards the circuit breaker. That's what a relay does in electrical engineering. In our power system, for electrical engineering students, that's what we teach. That relay is a fault sensing device. Okay, but here the relay acts as a switch here, which will turn on and turn off the supply. Okay, because when the supply is given, then only the heating element will get heated up. Okay, the timing will be provided in this relay control circuit. Okay, so for certain duration of time, the supply should be connected to the heating element. So time is decided. Okay, the time is set in this relay control circuit. For how much interval of time, for how much duration of time, this supply should be connected to the heating element is set in the relay control circuit. Okay, so based on the time setting of the relay control circuit, the supply will be connected to the heating element. Okay, as soon as the time is over, the supply will be disconnected from the heating element by this relay control setting, the heating element will get heated up. Okay, and the heating element gets heated up. What happens is the furnace is also gets heated up. Okay, because of the heating element, furnace gets heated up. Up to what temperature the furnace has got heated up is sensed by a sensor. Okay, sensor is connected here. The sensor will sense the temperature of this furnace, and that temperature, which is in analog form, is converted into digital, and it is displayed on the digital display with the help of an interface. Okay, so the help of an interface, the signal actually, digital signal is given to the digital display. On this display, what is the temperature of the electric furnace is displayed. Okay, now in this case of since it is an open loop control system, if whatever temperature is displayed, if I am not satisfied with that temperature, automatically I cannot control the temperature of the furnace, because the temperature in the furnace is depending on the duration of time that is set in the relay. Okay, so based on the time setting of the relay, the heat will be produced in the electric furnace, and that will be displayed in the digital display. This is the disadvantage. Automatically, I cannot control the temperature if I want to vary the temperature, because it is depending on the time setting that is provided in this relay control. This is the open loop control system. Okay, so let us see the same control. These are all the theorem what I have explained just now. It is in some textbook language. Okay, so what I speak is in my own language. Means of course I am speaking in English, but the way in which people can understand. Okay, now in the case of closed loop control system, in this case also temperature. This is also an example of a temperature control. Okay, so we want to heat the electric furnace to certain temperature. Okay, so in this case, initially a controller is, you can see here a controller. Control is nothing but a digital control circuit or computer or a microprocessor. So this controller, some reference temperature is given, reference input is given. What is that input? Desired temperature. Okay, I want the temperature in the furnace to raise to so on to degrees Celsius. Let us consider, just for example, earlier we have seen some 140 degrees Celsius. So let us consider same example. I want the temperature in this furnace to raise to 140 degrees Celsius. Okay, that 140 degrees Celsius temperature is fed as input to the controller. Okay, so this controller will generate an digital output. Okay, so it seems as if it is A to D. It is not A to D, it is D to A. Okay, digital to analog converter. This is digital to analog converter. We will always write from left side to right side. Ante kada? We always start from left to right. So don't confuse here. This is not analog to digital converter. This is digital to analog converter. Don't confuse. Okay, it will generate a digital signal which is converted into analog signal here. Okay, and that signal is amplified and given to the relay. Okay, based on the signal given by the controller to the relay, okay, the relay timing will be set. Okay, relay timing will be set. Okay, so based on signal that is received by the amplifier. Of course, without supply, cannot be heated up. Okay, so the main source of energy is applied. Relay timing will be set, and the electric furnace will be heated up. The sensor will sense the heat, and it will generate an analog signal. Okay, that analog signal is converted into digital signal through an interface. The digital signal is given to the controller, and on the display, the temperature will be displayed. Okay, if the display temperature on this controller is same as desired, then it's okay. Okay, if it is not same as desired, again the controller will generate a signal. Okay, a digital signal. It is given to the digital to analog converter. Okay, this analog signal of this converter is amplified and given to the relay, and this process continues till this desired temperature is obtained. Okay, so controller will compare whatever temperature is measured by the sensor. Okay, of course it is in digital form with the reference input. If it is desired, then it's okay. Otherwise, the process continues. So this is the temperature control of closed loop. Okay, This is what theoretically everything whatever it is. Okay, next its example is traffic control system. Traffic control system of open loop system and a closed loop system we will discuss. Okay, if we consider the open loop system, now you know it is a common general example, isn't it? So usually we people move outside, will go around. Sometimes whenever there is a crossroad and all, in such areas traffic signals will be there. Okay, so of course time setting will be provided to the traffic signal. We will be waiting for the traffic for the time setting whatever is there in the traffic signal to go to zero and show a green light so that we can move on. Okay, so if only time setting is provided in the traffic signal, okay, then irrespective of the density of the traffic, okay, sometimes in some roads heavy traffic will be there, in some roads light traffic will be there. Okay, the density of the traffic will be low. In some roads, density of the traffic will be heavy. Okay, so if we are able to vary the time setting of the traffic control signal based on the density, it will be more convenient. But in the case of open loop system, simply time setting will be there, irrespective of the density of the traffic. Then such a traffic control signal comes under open loop control system. Okay, so here, irrespective of the density of the traffic, simply time setting will be there. Okay, and based on the time setting, the traffic will move on in those roads. Okay, so let us go for the closed loop control system. In the case of closed loop control system, Mama, based on the density of the traffic, okay, so how much density is there in the traffic is measured continuously. Okay, so in all the directions, okay, and it is measured continuously and it is fed to a computer, okay, or to a controller we can say. It is fed to a computer based on the density. Automatically, the time setting of the traffic signals will be varied. Okay, so because if it is a heavy density road, then the time required for that heavy density road to clear is more. If it is less density, traffic density is low in the road, the time required is low. Okay, so based on that, okay, so based on that, whatever density is there on the roads is continuously monitored, okay, and that information is fed in a computer, and this computer is connected to the traffic control signal, so it will generate, based on that it will generate an output that is fed to the traffic control signal, and the traffic control signal timings will be varied now and then depending on the density of the traffic. Okay, this comes under closed loop system, traffic control of closed loop system. Next example, numerical control system. This is the last example. I will conclude after this. Okay. Okay, I will make it fast. It is already 45. Of course, we have been waiting initially for 5 minutes for the students to get into the class. Okay, that's why there is a delay. Okay. Next, on the numerical control system, let us discuss open loop and closed loop system. Okay. So here there is a cutter here. I'm going for open loop initially. There is a cutter here. Okay, you might have seen the lathe machine. I don't know how many of you have seen in your workshop. So I had a lathe machine job in the workshop. Okay, so we have to a piece metallic piece will be given to us. Okay, so using a lathe machine we have to cut the metallic piece. Okay, okay, so we have to cut the metallic piece in the workshop. Okay, so here P is the work piece. Okay, it has to be cut. Okay, so depending on the instructions given to the cutter, it has to cut the, there is a cutter has to cut this piece. Okay, so initially a magnetic disc. Okay, magnetic disc, you might be knowing what is magnetic disc. You might have learned in the case of even in your SPLD subject. Okay, in flipping gauge. Okay, so all the information in this disc are stored in the form of binary. Okay, the binary form information is stored in the magnetic disk. Okay, means what should be the shape of the piece, workpiece? In which shape this workpiece is to be cut. Okay, in which shape it should cut? This cutter should cut this workpiece. Is which is already fed as input in the magnetic disk. The information is stored in magnetic disk. Okay, so there is a reader here to which this magnetic disk is connected. So this reader will read the information of the magnetic disk. It will generate a frequency modulation pulse. Okay, and that is in digital form. That digital signal, frequency modulated digital signal, is converted into analog signal by this digital to analog converter. That means this analog signal, whatever is generated, it is amplified by an amplifier and that is given to a servo motor. Okay, in your second unit, we have the servo motor topic. What is a servo motor? How it operates? What are all its functions? We will discuss in detail in your next unit. Okay, at present, whenever we say motor, you know what is a motor. Okay, it converts some electrical energy into some mechanical energy. That's what it is. Okay, so it also servo motor will rotate with some angular position. As the shaft of the motor is rotated, the cutter, the position of the cutter on this object or the piece which is to be cut will also vary. Okay, so we can depending on the angular rotation of the servo motor. Okay, so if there is any change in the position of the cutter on this workpiece, it cannot be detected in this case. Okay, due to some disturbance, some external or internal, if the position of the cutter on the workpiece varies. Okay, if it cuts more a portion of the workpiece, that also cannot be automatically changed in the case of this open loop control system. That's why we need to go for the closed loop control system. So in the case of closed loop control system, you can see here, there is a controller. Okay, there is a controller here. So magnetic disk is there in which information is fed in the form of binary. This binary information is read by the reader. Okay, it will generate a frequency modulation signal. Okay, this frequency modulated signal is given as input to the controller. The controller generates the modulated output, which is in digital form. That is converted into analog. Okay, that is further amplified and given to the servo motor. Okay, and based on the input that the servo motor receives, the angular position of the servo motor will vary and the instructions will be given to the cutter. Based on that, the cutter will cut this workpiece. Okay, so if here you can see in a closed loop system, the speed of you can consider this line as the shaft of the motor. We can say just for example, I am telling you, it's not the shaft, of course, but I am just for example, you know how to measure the speed of a motor. Okay, so here they have connected a tachometer. The output of the tachometer speed is continuously fed to the amplifier here. Okay, so based on the analog signal that is coming from the controller, okay, of course, controller will not generate analog, it will generate digital only. This converter converts that digital into analog. Based on the signal that is sent by the controller to the amplifier, based on the speed that is fed to the tachometer, this amplifier will amplify the signal and and give input to the servo motor. It will give instructions to the cutter so that it will cut the workpiece. Okay, so the cutter position. Okay, what is the position of the cutter? It is continuously fed back to an analog to digital converter. Okay, there is a feedback signal here. This is an analog to digital converter because the cutter position is an analog signal that is converted into digital and given to the controller. Okay, the controller will compare this reader instructions, frequency modulated signal that is coming from the reader, and it will compare this feedback signal. Both are compared. If both are same, then the role of the controller is nothing. If both are not same, it will generate an error signal. Okay, it will modify the signal that is coming from the based on the feedback signal. It will modify the actual FM signal that is given to it. It will produce a controlled output that is given to digital to analog converter, and it is amplified, given to the servo motor, and the cutter portion automatically varied so that the desired portion is cut based on the requirement. Okay, so in this case of closed loop system, cutter portion is continuously monitored and fed back to the controller. Speed of the servo motor is also continuously monitored and it is fed back to the amplifier. So closed loop means controlled action takes place. Automatic control action takes place in the case of your closed loop control system. We have discussed these three examples. Okay, so if you want to know more examples, you can go to the internet or you can go to the textbook. Okay. So I'm concluding. If you have doubts, you can ask. Anybody? Otherwise, I will take the attendance. Huh? If you have doubts, you can ask them. Anything that you people want to ask? Okay. So I conclude that everything is clear to you. I conclude that each and every topic, whatever I discuss is clear to you, isn't it? Okay. The material has been uploaded in your Google Meet, not Google Meet, in your mail, isn't it? The PPT and the material both have been uploaded. You can go through it. Okay. Okay. It will be clearer to you. Okay. Same whatever I am discussing in the class, same PPT also have uploaded in your mail. You can go through it. Okay then. I will take the attendance. Don't leave. Don't leave the class. I will take the attendance.